Okay, hello everyone. I'm Shi,
And I'm Isaac.
and our project is going to be exploring how deception and defense against deception will work in a Among Us like environment through reinforcement learning.
And this is basically the setup of our game. On the right, you can see a visualization of the map. So we have four spaces our agents can be in. One is electrical, navigation, hub, and med bay, and all the rooms are connected to the hub. We have three, five, or seven crew members plus two hidden imposters. The imposters know who each other are, but the crew members don't know who the imposters are. Each round has up to 8 turns. The crew members have three options of what they can do. One is to do a task, one is to move to another room, and the other is to report a dead body. And the imposters have two options. They can either kill or move to another room. After a meeting is called, there are like three parts to it. So the first part is that each member will give one claim about their state. This could either be their location. For example, Agent A1, was in Medbay. Who I was with. For example, A1, was with A6, or an observation. I saw A6 killing A1. And then the next stage would be each player can make a public response. So that would be pass, accuse, defend, agree, contradict, or question. So on the top right here, you can see, for example, A8, which was an electrical, is defending A2, while A3 is questioning A2. And then the final stage is the voting stage. So each of the agents will aggregate their private data known only to them, so their state, with the public data that was just communicated between the agents to make a decision. So on the bottom right, you can see A3 voting for A2 or A5 voting for A8. This is our research question. To dumb it down, it consists of two parts. The first is a statistics question. So given a pile of accusations, how can the agents best aggregate them to their benefit? And the second is more of a dynamic question. So, to what extent can the crew members and imposters co-adapt to each other's evolution as they train with reinforcement learning?
So to answer these two questions, we place the players, both the crewmates and the imposters, as reinforcement learning agents. These agents will learn through the proximal policy optimization policy, which is an efficient reinforcement learning method that allows the agents to converge with respect to their rewards efficiently. In this case, since we want the imposters to have not the exact same behavior, but ultimately achieve the same goal, we have the imposters share a policy, but with an ID feature that allows them to act differentiatingly, but ultimately try to converge towards the same goal of winning and killing all the crewmates. And then to address our co-adaptation question, we first begin with a scripted crew from which the imposters will adapt against. Then we have, after the imposters are trained and we freeze their weights, we then have their crew as reinforcement learning agents to adapt against the coalition that has just learned. And then finally, we have the coalition adapt against that learning crew. For single round games, the rewards are given based on who is ejected. So, for example, if an innocent person is ejected for the imposter, they will get like a positive reward. Otherwise, if an imposter is ejected, they'll get a negative reward. Okay, so now on to our key findings. So we have four findings in total. The first three will be only exploring single round scenarios, and then the fourth finding will be generalizing to the entire game with multiple rounds and multiple meetings and things like that. So our first finding regards what the imposters learn to do. So I have these four plots here, each of which on the horizontal axis we have the amount of training updates, and on the vertical axis we have the amount of or we have a variable of interest. So, for example, our first variable of interest is the proportion of innocents that are wrongly ejected. We can see that as we progress through training updates, the rate at which innocents are wrongly ejected actually goes up, which means that the imposters are successfully learning to frame innocent people. The second variable of interest is the rate at which the votes from the imposters converge on one single target. So we can see that similarly, the rate at which votes converge on one target also goes up, which means that throughout the rounds and throughout the episodes, the imposters are learning to coordinate their votes more. The third one is that the culprit is successfully shielded. So and third variable of interest is the rate at which the guilty imposter, the one who caused the incident, survives. As we see through training, the rate at which the guilty imposter survives increases, which means the culprit is being increasingly successfully being shielded. So these three findings are relatively intuitive because the agent is trained on a reward basis that rewards innocents being ejected and imposters being shielded. So framing should succeed and the culprit should be shielded. And it's easier for them to succeed if they coordinate their votes on one person. However, I guess the unexpected finding is the fourth plot here, actually. So on our variable of interest for the fourth plot is the coalition false claim rate, or the rate at which the imposters make lies in their public statements and such. So we see as they train, they actually manage to decrease the rate at which they're lying. And this is kind of counterintuitive because you would imagine that by deceiving, the rate at which they would be lying in order to do that deception is going up. But no, instead, they're managing to deceive while like making not false statements. So our second finding explores the aggregation of the public testimony that we had mentioned before. So after everyone makes a testimony publicly, the all of the crewmates have to aggregate the messages in some way and then make a vote based off of that. So we test five methods. So the first three methods are just like typical statistical measures of censor. And then we also test soft credibility and sharp credibility. So these two latter methods basically weigh people's opinions based on how correlated they are. So for example, if we have like persons 1 through 4 all accusing person 5, an external observer who is using this soft credibility or sharp credibility will weigh those accusations that fall on that one target more. And we test three cases for the imposters. One is when all of the imposters are honest. So they can only make factual statements. One is when one of the imposters can lie, and one is when both imposters can lie. So we see initially, the soft credibility and sharp credibility perform very, very well when everyone is honest. Like almost no innocents get ejected, while mean, median, and trimmed actually get like around 15% of innocents ejected. But when there's one liar, all of them are about the same, with mean being slightly worse in this case, with 3 crew members and 2 imposters. But when there's 2 liars, the soft credibility and sharp credibility actually get more, in a sense, to get falsely ejected compared to the other measures of censor. And the reasoning behind this is because these credibility methods are based on how like corroborated or like correlated the opinions are. By having 2 liars, these 2 liars can both like focus their opinion or accusation against one single target by like extension, increase their like trustworthiness or their weight because they're voting on the same person. This finding is when defenders actually learn to fight back. On the horizontal axis is again the episode number, and then on the vertical axis is the false ejection rate for this picture in this case. The first section is when the imposter first adapts against the crew with the fixed policies. And then the blue section is when we have the crew now learning to adapt against these imposters. And then finally, we have imposters adapting against the learned crew. This is relatively consistent across all differing crew sizes of 3, 5, and 7.
Coordinated imposters will learn to exploit corroboration-based defenses, and learning defenders can temporarily contain the coalition. And lastly, the coalition then adapts and recovers its